It's your time with the wonderful, and I love so much this force. This is the VolksForth from the GermanFig, and Ulrich Hofmann will show us a little bit about.
A little bit about it. Yeah, VolksForth, 35 years later. And so let's see what we want to do. We would want to look at what VolksForth actually is. I give some short introduction. We look a little bit at its history and its features and the different platforms it runs on. And I recently had a look as being one of the authors originally, again, a look at VolksForth and find that it has a very interesting collection of very special features that you don't find in any other force system. And I picked 4 of them, and we will discuss them, like dynamic binding of local variables, the heap data structure, headerless words, and interactive conditionals. And there are many others, like it has a block buffer system, like many other force systems, but it could change the amount of buffers at runtime without crashing. And so you, if you're tight in your application code, you just say, well, I can live with 2 buffers. And you get another 2K with respect to the normal 4K 4 buffers that were there. And then VolksForth has been revived, and we will look a little bit in the future and get some conclusions. So, yeah, the VolksForth was actually developed, I think, initiated by Klaus Schleisig, who's also in today's meeting. Hello, Klaus, welcome. And there was a group of people that were just surfing on the upcoming home computer wave, like C64 home computer and Atari ST computers, and I myself was involved with CPMs, Z80 systems, and so in 1984 the Forthgesellschaft was founded, and in 85 we started developing a system for the members of Forthgesellschaft. And so there were some guys that had 6502 computers, others like myself, 8080, Z80, others had Atari ST with 68,000. And Klaus was involved with the DOS version doing 8086 development. So from 85 to 89, we developed this, and we look at the feature set that VolksForth actually achieved in a moment. And after 89, well, the mission was more or less completed. There was a common system on all the platforms that we will also look at that worked fine, and that yeah, was more or less complete. And so people moved on to different other things. And but still, VolksForth is the foundation of other systems that are still in use today. It evolved into BigForth, a 32-bit system on the Atari ST and later on the PC, and Delta T-Force, a commercial system that I was involved and Klaus was involved in. And eventually, BigForth evolved into GForce. If you are interested in the history of systems, force systems, Anton Ertel collected a huge family tree of force systems. And if you want your force system to be included there somewhere, because you said I'm inspired by FigForce and also by F83 or whatever, then just give Anton a note. He will happily include you in this family tree. So, but the actual VolksForth development stopped more or less in 89. And then in 2005, Carsten Strothmann said, well, he's very active in the retro computing scene. He said, well, we have a great development system that runs on these old retro computers, on the home computers at that time. And so there was a revival movement. He collected all the diskettes and put them on GitHub. And so you can get hold of the old data and old source code of that time. And then Philip Zembrot jumped in, and Carsten and Philip started to continue development on VolksForth. So they actually did some revisions, clarified things, scanned all the handbooks, and started to make it UnsForth compliant. Yeah. So what is VolksForth? It's a self-contained interactive programming environment that once you boot it, you can do complete development inside VolksForth. So that's really nice. So no need to use any external tools. That's the idea. At that time, computers were 8-bit computers, and the typical thing was that the Forth systems were 16-bit, and so that's also what VolksForth is. It uses indirect threaded code as its execution technique, which I still think is very pleasant to use and very easy to understand. It allows you a lot of good manipulation of the code, even when it is already compiled. It runs in 64 kilobyte because if you have addresses that are just 16-bit, that's it. So the system takes some place, and your data takes some place, and then there is not much space left for the application program, looking at today's amounts of memory, even in microcontrollers. So, but later systems did segmentation, separated headers from the code, put the stacks in different areas, like what you did to overcome this. So it adheres to the Forth83 standard at that time. That was in '85. That was the hot topic. And thus it's also called VolksForth 83 in official terms, but I just refer it to VolksForth because I don't see it tied to the Forth 83 standard. It's just that it happened at that time. We had a very huge, exhaustive manual handbook, actually, that was printed at that time. PDF was not common, and so we handed out with the distribution of the diskettes, and people also got the chance to learn about this. It was mostly written in German, and that's probably something that we want to change. We have the scans, they will be OCR'd, and then we will go ahead and translate them in English and with volunteers to other languages. Foxforce had an intrinsic assembler, so at any time, if you say performance is not right, you could go ahead and rewrite a high-level definition into code, and thus do this on the hotspots, which you would identify also by benchmarking. There are also profilers, but they are not in the core distribution, that allow you to identify the hotspots, and you could easily speed up words by this. The system had an embedded full-screen editor. Source code at that time was based on source blocks or source screens, 16 by 64 characters normally. Yeah, but it was very nice. It has search and replace capabilities, very easy shadow screen support, whatever for automatic documentation or for good documentation and so on. You had a decompiler for interactive and also for an automatic one. The interactive decompiler is especially interesting if you do compiling words, and the automatic decompiler doesn't know about the new compiled structure in the first place, then an interactive decompilation is very, very helpful. We had a multitasker, we had a single step tracer, so all the bells and whistles that you think, but VolksForth never, well, it ran on its own on certain homebrew systems. That's where it started, but the typical VolksForth 83 platforms had an underlying operating system, be it TOS on the Atari ST, or well, the ROM in the C64, or CPM or MS-DOS, yeah. The system itself came with complete source code and was written mainly in Forth itself. There was a meta compiler that allowed to regenerate the system and port it to different platforms and evolve it appropriately. And that was the way it does. We shared the source code of the core and made it actually very similar on the different platforms. So there was C64, as I said, CPM, Atari ST, DOS PCs, and all of the source, the VolksForth core was more or less identical on all platforms. So you could port programs very easily from here to there on the supported platforms. And each platform itself had system-specific extensions, so to make full use of the system. And let's have a look at the different platforms. So there's the C64 version that came on 4 diskettes. At that time, the diskettes had 140K space, and if you wanted to load a program, you had to swap 2 of the disks constantly to actually load the appropriate source code and then have the right source code available. Because of the strange resolution of the C64, which was supposed to be used with television sets, the UltraForce, which it was also called UltraForce on the C64, used a screen editor with very strange screens of 24 lines that had 41 characters and 1 line that had 40 characters. So the lower right corner was dropped out, but if you calculate this, that gets you 1 kilobyte of characters. Very nice. And yeah, so it was used by a lot of people that had C64s at that time. And today, if you want to run it, you can run it in an emulator. For example, the Vice emulator that is used in the retro gaming scene for running the old C64 games, but you can use it to also run Foxforce on it and get the old feeling of how things were at that time. The system I was involved with was Foxforce on CPM. It was ported to CPM and CPM Plus systems, which was in itself a wide variety of hardware, where the hardware abstraction was mostly delivered by the CPM system. And there were also some home computers like the Amstrad Schneider CPC lines, 464, or similar computers with cassette interfaces. And you could use it there, and they had graphics capabilities. So the Amstrad CPC version adds turtle graphics and other system-specific extensions. Also, this system has interactive conditionals, which we will have a look at in just a moment. And if you want to use it today, at that time, a typical CPM system had a Z80 processor with 4 megahertz execution frequency, and things were, well, slow, comparable to C64. I used the emulator, and C64 was a little bit slower even. But you had to be patient at that time. But if you today use a modern CPU and use, for example, the Yase emulator that emulates CPM, you get something like a 150 megahertz or 200 megahertz Force Z80 CPU out of it. It's blazingly fast to use it there. Or you can even run the 8080 version online. There are people that provide CPM inside the browser, and then you can go ahead and have a look at it. Yeah, right. It has also been ported to the Atari ST, and then there was support for the GEM environment, the window environment there, and the DOS-like operating system that was the basis of the Atari software. Today you can run it again in an emulator like Atari, for example, which boots TOS and the GEM, and then you can just run Foxforce on top of it. Or you go with the DOS version, which came with a DOS interface, and its outstanding feature is the status line. That is something that if you started, you immediately recognize, where at the bottom you would see the items on the stack, how much dictionary spaces are available, and you see it's 25K available on the DOS version if you boot up the vanilla system. And the open file and the search order and things like this. If you want to run it today, use DOSBox to do it, and that works quite well. And also, it's blazingly fast being there, not comparable to an XT at that time when we did it. Yeah, so that's the outstanding features that I see with Foxforce was it was very easy to understand. So you had the full source code and the capability to just jump to certain certain parts of the source code, have a look at it, and understand it. It had a very complete feature set, what you needed for development, and it was somehow self-contained. So you didn't really. I had the feeling you need something else to do it. With a full screen editor for the source blocks and the nice capability, it had lines and character stacks to rearrange the source code, which were very handy. That worked quite well to do it. And with a meta compiler, you could do recompilation, porting the application to a specific to other platforms, or do specific tweaks for applications that you wanted to do. There was also a methodology how to port from one thing to the other. In the source code, you find for many code words, you also find high-level definitions. And the way to port from one system to the other was to substitute the code definitions by their high-level definitions. The system slowed down by this a lot, but more of it was written in high level, and then only a few primitives in code remained. And then you needed to write these in the assembly code of the new platform and do cross-compilation. And in the end, you get an image. Once it booted up, it was very slow because it contained all the high-level code. But then on the new platform, again, self-contained, you could just go ahead and substitute high-level definitions by the new assembler, step by step, always knowing when you make an error, what word caused the problem. So that was very, very nice. And it was a pleasure to port it to a different system like CPM in my case. And then Foxforce has a very interesting set of special features that I have not found elsewhere. Probably if you look at for it, you will get some of these. And of course, you will let me know. There's this Forth system that has the same feature. Of course, we don't claim any exclusivity, but I would like to show you some of them. So one nice thing is the dynamic binding of variables, so they become local variables. There, in Foxforce, there's a word push, which you use in the way push variable, and then it saves the current value or the return stack, but it doesn't matter. It saves the current value and allows you to change a variable, and it will be restored whenever the definition where push is used is exited. So as an example, you could define a word that regardless of base will always output a number in hexadecimal, but will not change base at all. So it stays as it is, and you use it this way. Base push is the old value, whatever that is, on the return stack, so it will be only locally changed in the rest of the definition. Hex goes to hexadecimal, dot outputs the number in hexadecimal, and the semicolon will make sure that the old value is restored in base. So if you are in decimal and you say 100 dot hex, it temporarily switches to hex, outputs the number in hex, and restores the old value, which used to be 10 because of decimal, and the dot will actually print it in decimal, so you get the output 6400. The push feature is 3 or 4 lines in implementation. I think that's mainly also a speciality in Foxforce. All these features that I present are very easy to implement. You are surprised if you look in the source code how few lines there are to implement these nice features. So that's and you can use it for your own variable. Base is just a variable. It's a user variable actually because of the multitasker, but any ordinary variable will do as well. So if you want to change it for some temporary time, you can use base. The push on it, that's quite easy. Right. Today, if we want to use dynamic memory, there is allocate and free ANSI standard. Yeah? But at that time, Forth83 didn't have these kinds of things, and Foxforce provided something that is similar. You could, it had a heap structure. It has stack and return stack, and it also had a heap structure where you could allocate certain amounts of data. And the word used for this was H-allot. You just gave it a number of bytes that you wanted to have, and it would reserve it. Okay, again, a typo, this is heap, of course. If you issued heap, then it would give you the address of the last allocated chunk of memory. The difference between allocate and free and H-allot is that you could not release certain fragments of memory, but you have to release all the reserved memory at once. And this is what the word clear is for. So let's see how it works. So you do just output where the heap actually starts, where is allocated memory. That's at this address, and then you can allocate 300 bytes, and then you ask again what is the start address of the newly allocated memory. That's 300 bytes less than it used to be before, and then you can just deal with that memory. You know it's 300 bytes long. You can just initialize it whatever you wish, and you can type some stuff of it. And once you're done and you say, okay, temporary memory no longer needed, you do clear, and then it resets this to its original version. The heap is actually located below the data stack. And if you H-allot something, then the stack is moved under the hood without any program noticing it. So it's below the bottom of the data stack. So, which is only important if you happen to capture some addresses of stack items, but that's not what you normally do. Yeah, so that's nice. So there's a way to have temporary memory that could be released at once, and this is actually used by for headerless words. Another feature that I haven't seen in any other force in this way. Many use, or some systems use the vertical bar to mark headerless words in target compilation mode, but not in an interactive system. Well, that's something that is unique, I think. So you store the header not in the dictionary, but then in the heap. We're doing an appropriate indirection to actually know where it is. And if you now clear, then it unlinks all the headerless word names so that their names are no longer visible, but the body remains. So you can define words that lose their name And this is, of course, for memory preservation, to save memory, but also to just make intermediate helper words no longer be available for the application program. So as an example, we could do a headerless definition hello, just outputs hi. We can use hello in another word greet that calls it twice. And then if we do words, we see greet and we see bar hello, which means attention, this is a headerless word, and some other words. And we can invoke hi now, or we can invoke hello now, displays hi. We can invoke greet, displays hi twice. And if we clear, then we get rid of the temporary name. So hello can no longer be invoked, and but we still can invoke greet. It displays hi as before. And so hello is some internal word that is not used on the outside, and greet is the interface to the application program in that sense. Right, so that's headerless words. One feature that the CP/M version of Foxforce had, which was also astonishingly easy to implement, is interpret mode control structures. You can, of course, use them inside colon definitions, but you can also use them outside colon definition. This is done by temporarily compile an anonymous definition. And once you end the control structure, the outermost one, this gets executed. But to allow extending the dictionary inside the code that you execute, it's moved out of the way and executed somewhere else. It could be done on the heap, but it's actually moved to the return stack and executed there. Let's have a look at how it can be used. So in interactive mode, you can just do 10.0 do i.loop, and then it will just do it. This is useful for data structure initialization. So you can just create an ASCII table of uppercase ASCII values, and you just loop through the characters, and for each character you convert it to the uppercase letter and comma it in the dictionary. Yeah, and although do and loop will compile stuff, it will be moved out of the way, so you can actually extend the ASCII table by this. And you can then later on just index in it and type the printable characters in it. So skip over to space and then type the remaining 96 ASCII characters in the first code page, which gives you twice the capital letter because the initialization did it that way. Yeah, so just to give you an impression, of course, you could do a temporary definition that does the initialization that you would just invoke here, but this would be a definition that remained in the dictionary, and although it's only used in the initialization of the data structure. And remember, we have a very, very small system, so being tight in memory, then every definition that is not used is waste, then that is to be avoided. Right, so that's mainly it. So let's have a look at the future. I talked already about the revival of VolksForth. It's used in the retro computing community because they want to do new programs on classical computers, and they are, of course, looking for development environments that can be used of advantage there, and VolksForth is an environment like that. The data that Carsten collected is also available on SourceForge. You can download the binaries, or on GitHub for further development. You can find all the versions, and it has been ported to Apple I and also to Nintendo systems, depending on the CPU. So that's quite handy, or some handheld computers. So there are some more ports available than the classical ones. And also it runs the haste test that we saw earlier today as well. Some systems are already unforce compatible to move this. And I already talked about the idea of translating the handbooks. We only have scans and they are not OCR'd right now. So this needs to be done. And once we have them machine readable, then translation should be easy thanks to the help of DeepL and some native speakers that will just go over it. So that's something that is planned for the near future. And so my conclusion is, at that time in '85, we developed a quite versatile tool during this home computer time. And that was really a pleasure to use at that time. And after reinvestigating this, it's still a pleasure to use for me. Because it's so easy to understand and so compact, and it has what you need, and it's not overloaded at all. So that's quite nice. It's a foundation of BigForce and then eventually GForce. GForce developed further on, having many things, and is not as comprehensible as Foxforce was, but has lots of more features, and you decide whether you need them or not. There was this revival in 2005, and my judgment is Foxforce has many good ideas, and it's yet still easy to understand. So it's very pleasant to use. And we have this elaborated technique of porting it to other platforms as a native system. And I find it too bad to let it fade into oblivion and just let it forget. And it's worth to be ported to new platforms, and that's probably what I'm thinking to do as well, because it's as a tool, it's very important to also get a deep understanding of what it is. If you're an engineer and you have to be held, or you are held reliable for the things that you do, then you want to know what's going on, and a good understanding of the system will allow you to actually give the promise that the application that you do will actually do what it is, and there are no surprises in some underlying software. So for certain areas, for other areas, you just want to make it work, and you cross fingers that it works and get the experience. Yeah, but anyway, so are there any questions? Thank you very much for listening.